Okay, class, this video is going to walk you through the installation construction process that we're going to use for this semester. So the system we're going to work on is this hexagonal pattern generated from a lunchbox plugin between two different surfaces. And this is one component, a small mock-up that we're going to be making this week to test out the system. What you're looking at here is a 12-foot tall 2x4. I've marked out like a 36-inch radius or a 6-foot diameter around that 2x4, just to denote what we think will be the kind of limit in terms of how far off of the 2x4 we can structure each shape. And then what you can see here in green are 4 panels that are tied back to the post with some tension, probably some rope that we'll use to structure the piece off of each of the 2x. And then down on the ground, you'll see the unrolled shapes of the 4 panels, each with dots on them, and then the unrolled shapes of each of the hex shapes that you see here. So number 25 would correspond with this flattened panel down here, number 25. What you can see is that we've also set this up to constrain it so it's no more than about 60 inches wide, allowing us to fit one of these split in half into the blue laser cutters, which have a maximum width of 32 inches. So we have an inch to spare on each side. So the script we're going to go through today will show you how to actually generate all of the hexes and unroll them onto the ground to be able to see what patterns you're going to make. We'll explain more on Tuesday the assignment for this, but I wanted to get you started walking you through the Grasshopper script for generating all this. I'm going to hit show here so you can see the underlying geometry. Here you can see these 2 surfaces are being used to generate the hex shapes. The maximum depth here that we've set is about 8 inches, and it goes down to maybe around 4 inches in depth as a minimum. Over here you can get a sense, and part of your assignment is going to be to generate your own, but we're estimating a limit of around 12 of these Christmas tree 12-foot tall 2x4s to be used in the salon to generate this. And probably around 400 hex shapes. So that'll end up being about 10 that you'll be responsible for. Each student will be responsible for. Okay, so on to the script. I'm just going to start a new file here. I'm going to keep it in inches and open up Grasshopper. I'm going to model a couple of things here in Rhino first just to get us started. So firstly a 2x4, so 1.5 inches by 3.5 inch rectangle, and I'm just going to extrude that up 12 feet just to give us some context and some scale. And then in elevation I'm going to just draw a couple of curves to generate a surface with, and these you can just kind of have fun with for now. And I'm also going to draw that 6-foot diameter off of the 2x4. So we get a sense of how far away we can move each of these curves. I'm going to just scale them up a little bit. There we go. And I'm going to move them up vertically. Somewhere around there. We're going to start the ropes probably from about a foot down on the 2x. So these are going to want to be constrained to say between 6'8" or so, which is your typical kind of door height, and 11 feet. So you have plenty of room to work with in terms of the shape and profile of the surface that you're working with, but for this one we're just going to keep it small so that it's easy to manage within the script. So I've just lofted the two shapes together. If you want, you can turn on control points. Actually, I think I'll rebuild this surface first. Let's say a 6x6 grid, just so we've got a simple setup here. I'm going to get rid of those original curves and then turn those control points on. And I can just kind of mess around with this to make it a little bit more interesting. Okay. Really doesn't matter here just for this test. What I am going to do is make that second surface, and I'm going to offset this surface using offset surf. F to flip the direction. I'm going to make sure that solid is turned off, and then I'm going to go ahead and move it 8 inches. And then rebuild this one as well. Same number of curves. In this case, again, I'm going to manipulate this so that the hexes aren't exactly the same shape. So because I want to keep the depth of this at 8 inches, I'm only going to be moving these. I'm hitting move and vertical to kind of constrain my movements to only vertical moves and only back down towards the original surface. Sort of reducing the offset in spots. But this also makes the hex look more interesting in terms of the differences between these two surfs. So once you get a little bit of difference, it also is going to help in terms of trying to fabricate the hex with these two shapes. Okay, we've got everything now to go into Grasshopper, so I'm going to pull that up. And I'm going to bring the two surfs in, just using a surface component. Copy paste it. Top one in the top surf and bottom one in the bottom surf. And then I'm going to bring in this hexagonal cell component from Lunchbox. It's the same one right here, hexagonal cells. And I need 2 of these, one for each of the surfaces. And you can see that it basically divides up the hex into 2 halves. I'm going to set this so it's split. And the size of these looks roughly approximate right now. We'll eventually kind of come back and set these. I'm just going to move them to 8s. They have to remain exactly the same. So I'm going to put both sliders into the U's and V's components for each, so that if I do change them, that they change equally. So here it looks like, now that I'm at 8, that to get them more evenly shaped, I'm going to have maybe like a 10 by 7. The sides are approximately the same there. So what I want to do now is actually remove the cells which are not complete hexagons, so that the edge of my shape is following the kind of hex profile of the surface itself. So in order to do that, I'm going to explode the curves. So I'm going to take an explode component. And again, I got to kind of keep these separate. I don't normally like having this kind of duplicate information all the way through, but in this instance, it's sort of required. And what I'm working towards is using a sift component, which is going to allow me to sift out the hex shapes that aren't complete hexes. So all these ones around the periphery. And how I want to do this is if I put a panel on one of these explodes and pull this down, you're going to see that some of these only have, say, 5 points as their 5 points as the edge, and that's how I'm going to be able to denote one that doesn't have a complete hex, because a complete hex, of course, is going to have 6 points. excuse me, a complete hex is going to have 7 points because it completes all the way around and has 2 points in the beginning and the end. So what I'm going to do now is use a list length component to count how many of those components there are. And then I'm going to use a smaller than to create, to test to see if there are fewer than 7 points in that list. And that will give me a true-false list telling me whether or not there are fewer than 7 points in the given list. So each of these exploded hexes is going to have a number of points, and if it's fewer than 7, then I know that it's not a complete hex, and I can sift it from the list. So now what we're going to do is take the original cells, and our list structure has stayed the same all the way through here, and then we're going to use this pattern to sift out all of the components that have fewer than 7. So here you can see I've generated this sifted list, and what I'm looking for should be something like this. Now it leaves a lot of nulls in here, and you can use a clean tree component to actually clean out those nulls so that we're just left with the polyline curves of the original components. It looks like I might be having a graft problem here, so I'm going to graft these. There we go. Now I think I'm just left with the solid hexes. So you can see here when I select the cleaned list that all of the curves that are associated with these partial hex shapes are gone. So now what I can do is just copy these last 3 components and switch it over to this top piece. And I can leave this slider associated with both. And now what I've got is the top and bottom list. Excuse me, I need to sift this one. So I'm swapping out for the top hex shapes into this sift list component. So now I've got one clean one for the top and one clean one for the bottom. So the point here now is to loft these 2 shapes. Because they're a series of curves in each of these, if I were to just hold shift and plug them into the loft component, it would give me this giant swirly loft where it's trying to loft between all of these different hexes at the same time. I'm going to switch. You can see I've got all these empty lists still in this panel. The clean list component, if you look at it, removes the nulls. That's set to true. Removes invalid components. That's also set to true. But here the E is remove empty. And I also want to do that. So I'm going to flip that over to true. Now you can see we have a nice clean list left over. For both of these, they look the same. So what we're going to use in order to stitch these 2 lists together is an entwine component. And I need to subtract this last one so that there's just the 2 lists coming in. And I'll put a panel on this so you can see what the results look like. Basically, we're going to have 2 long lists of polycurves. And the first one in this one is the one that I want to loft to the first one in this one. So this isn't exactly right. If I were to plug this in, it still would try to loft all 26 of these. Almost always, and you'll remember when we've used this before, when you use an entwine component, you're also going to use a flip matrix component. So the flip matrix basically is like flipping the rows and columns in a spreadsheet. You'll remember us using this earlier. Now when I show what's coming out of the flip matrix, it's paired up 0 and 1 each of these polycurves, and now I can dump that into the loft, and you can see we get a nice clean set of hex profiles on these surfaces with all of the edge profiles removed. So these sift components can be really useful for trying to filter out information that you don't want to include in whatever component you're working with. So these lofts obviously are what we were working towards. And what we want to do now is to unroll those components. So I'm going to put an unroll brep component in. You can see when I plug this in, it's going to lay them all down here at the 0, 0, 0, the 0, 0 point. And so we're going to have to spread them out. The easiest way to do that is to use an orient component. And what orient wants to do is take your geometry, its original kind of centroid or some start point, and then a new point where it's going to spread them out. And we're going to, what we want to do is create a grid of points that we can use to lay these out, spread them out across the surface. So this rectangular grid component I just put in is going to create a series of points that we can move these objects to. So the base plane we can just leave as XY. The size of the cell, we can make something like 30. You know, we're going to be laser cutting these, so I'm going to make it 30 by 60 because I know that those hex shapes are going to be roughly twice the length of the of the laser cutter. We're going to cut each of them in half so they'll fit. And then the number of grid cells is going to be based on the number of shapes that you have. So I've got 27 here. So what I'm going to do is just set the integer in the x direction to 27 and set the integer in the other direction to just 1. So we basically have a grid of shapes here that we're going to, or a grid of points here that we're going to spread out these unrolled surfaces. So here's the geometry. We're going to use an area component to get the centroid of each of them. That's the start point, the start of the reference point, and then this new grid is the end reference point. Looks like what's happened here is the join was not set to true on my unroll. So what that did is basically created a whole series of separate little components. So I'm going to set the Boolean on this to true. And you can see what we're getting here is it's basically copying, because there's two sets of points here. It's copying our plane more than once. So what we want to do is, I think we want to graft. No, not the B's. Let's be the A's. Let's just try using these cells instead. Also not working. Okay, so what I've done to fix that problem with the grafting is to switch these the extents were already set to 27 and 1. If you want to make this script work no matter how many objects you have, you could take the list length and set the list length of your unrolled objects to the number of or the extent of the grid, so that's also the number of 27. But now if I have more panels, this script will continue to work. All I've done is add in an area component here to get the center of each of the cells, so there's exactly the appropriate number of components, and I've flatten this list before it goes into the orient component so that now I'm left with the 27 objects unrolled. I can put a tag on these, a text tag. That's also going to be based, I need to generate a series of text that can be associated with each of these so we can keep track of the number of the object and we can orient it to a place in the three-dimensional space. This is going to be really important when we have a lot more components going on, say 400. So the step size here is going to be 1. The count is going to be based on the list length again. So our list length right now is 27. The series starts with 0. We actually want to make the first component labeled the number 1. So what we've created here is a series of numbers, but we're going to treat it actually as names or tags for these objects. So the location of the tag is going to be the geometry. Is going to be the center of the cell, which is where we move the components to, and then the text is going to be this series of numbers. You can see right now they're all getting tagged onto all of the numbers are getting tagged onto all of the components. So I'm going to put a graft on there. Now we've got the number 5, the number 6, and so forth. This is a lot easier to see once you bake it. I'll bake it just so you can see those numbers tagged on there. And then if we want to do the same thing to the objects up here, it's easiest done if first we split the surface up based on these objects. So I'm going to take a split. See, I think we want to use a B-rep split. Let me just make sure this works. Yes, so this works. Basically what we've got here is I'm taking the original top surface and I'm plugging it into this split component. It's a split B-rep, and I'm splitting it with the lofted hex objects so that we're left with these surfaces. I'm going to bake this just so we can see what we're getting. And I'll select that group. Yeah, and it looks like it's not quite trimming correctly because I'm guessing that this surface isn't entirely intersecting those lofts. So what I'm going to do is take this surf and create an offset of it. Oops, not curve offset, but surface offset. And I'm just going to do this 1 inch down. So I'm going to put the 1 into this distance. Then I'm going to right click on it and make the expression -x so that surface goes. Oh, it was correct. I didn't even need to do that. So take that -x back off. So it's going down into the surface here. And then I'm going to replace that top surface with this one. And let's try, so this looks like it is also having a grafting problem. But let's just try baking it to see what we're getting. So I'll group it, select it, move it out, ungroup to see what we're getting. Yeah, so each individual surface is creating an outside one. So you can tell this is a grafting problem where each object is being recreated. So I'm going to graph that surface and see if we can reduce. I think we may need to graph the curves. If we can reduce how many we're getting. That's not doing it either. Let me try to figure this one out. Well, this will actually work out okay because what we're going to end up with is we're going to need to filter out some of these objects anyway. So what I'm getting is a product from this split component, and this is probably would just be easier done inside of Rhino with the typical split surface component. But keeping it here in Grasshopper gives us a little bit more control over labeling and everything else. We don't want to flatten it too much because we want to keep it organized the same way that these panels are so that we can find each shape when we go to unroll them. So with these split surfaces, we're going to go ahead and use that sift component again to sift for the area of each component. So I'm going to put the area in, and when I put a panel on the area, you're going to be able to see that there's one small and one large shape for each object. And so basically one small one, which is the one that we want, and one large one, which is the leftovers. So we're just going to put a larger than component in again on this, and it looks like anything larger than, say, 700 is going to result in a false conclusion, or excuse me, it's true in this case. So the list goes here, and the larger than results, the false trues go in there. And what we're going to be left with, hopefully, is the right appropriate surfaces remaining. I'm going to turn the preview off on that. I'm just going to make a surface component so we can visualize through the selection which one we're getting. Still 54. Oh, that's the, we need to clean the list again. Pretty much anytime you sift stuff out, you're going to have to clean the list. There we go. Now we're left at 27. Let's try baking that just to see what we get. And then if I ungroup this, it looks like that bottom list is exactly the wrong one. So the top one should be, in that case, the right one. So I'm swapping it in for the 0, baking again to test it. It looks like those were all the remnants. Ah, there we go. So here you can see exactly what I was hoping to get, which is just all of the hex shapes, the individual hex shapes. If I ungroup them, I'm left with just the correct profile. That's great. So the last component of this, again, is to tag the other hexes. So I'm just going to copy paste this hex tag, and we're going to put it onto the filtered loft components. I'm going to put a bounding box on these guys and a volume component, which gives me another centroid. And that centroid is going to be where we position the tags for these other components. And if I bake it, you can see here now we've got, using the correct list order, 1 through 27, 1 through 27, all of the components in our surface. So we've baked these 2 tags. Now we can bake the panels on the ground. I'm going to group those. We can bake the hexes back here, which is the loft. I'm just going to group all of this stuff. And this final surface we can also bake, which I had done once before. And if we close Grasshopper, hopefully we've got everything we need to start fabricating this guy. I'm going to switch it over to shaded, hide these 2 surfs. Great. If I take a look at this group and ungroup it, at this point this is a series of, this is where we're going to want to select some surfaces to tie back to for structuring this, and that's what we'll start to do in the video for Thursday, is talk through some of the other methods for working with this component. Okay, thanks.